Testing, testing. Okay, it's 1 o'clock. We're going to get started, folks. All right. Well, thanks. I don't really need this, but I'll use it. Thanks for coming to this session. I hope it's fun. It's fun putting together. It's the team we've got on this project that we'll highlight a little bit, and they have some other projects. Are just exceptional people. So I hope you have as much fun hearing this as we have talking about it. So I am going to speak first about high-rise buildings, but more than just high-rise buildings, large projects. Because essentially, by definition, a high-rise is going to be a large project. There's a lot of other projects out there that are equally challenged. And so I'm going to speak from an owner's perspective about some of the things with our reserve funds and contingencies and how that works and what's important for us to make good decisions on as early as possible. And you can see the agenda. These guys are going to go through code requirements and some of the things that we ran into that have been fun. State of North Carolina projects. Don't know if y'all know this or not, but we have a recommended amount of contingencies on our projects when we ask for funding from the General Assembly. If it's a renovation project, we typically hold 5%. If it's a new project, we typically hold 3%. On a large project, on a high rise, these percentages do not even come close. Think in terms of tripling. Absolutely, they just not come close. And you have to ask the question, why? What's going on with large projects? Percentages are percentages, right? They're scaled up. From small projects, the same percentage, they should work. They don't. There's a happy face and a sad face there. A happy face on the scale factor on these large projects is we all know what economy of scale means, right? You buy one Ford F-150, you get a price. You buy a fleet of 100 Ford F-150s, you get a much better unit price, right? Economy of scale. Well, the other side of that coin is the penalty of scale. That's what large projects face. There are some things that we divide equally from their own perspectives. We divide things like means and methods. As designers and as owners, means and methods are the contractors or the construction manager's point of view and responsibility. On large projects, it can't be. It can't be. Bring them on early, keep them forever, have open communication, be smart about what you do, because that leads right into costly things that you will never see. I've got some notes I need to take, yeah. All of our contingencies are for one purpose and one purpose only. That's minimizing your risk, right? Designers have contingency for things that they don't know, that they know will crop up. They're unknown unknowns. Contractors have contingencies because market fluctuations and the risk of being a contractor is certainly not any less now than it has been in all of our careers. And the owners have contingency to reduce and address risk factors from the owner's perspective. Well, just exactly what are those risks that an owner needs to have contingencies for? And I'll tell you that the penalty of scale comes from increased complexity of large projects. They have higher risk factors. They have higher potential for unseen issues. Now, why is that? If you've got a high-rise building, I'd bet 100% that you're not dealing with a greenfield site that's never been built on, never been developed, never experienced abandoned underground utilities and forced sewer mains that are still operational, but nobody put them on a set of as-built, right? And when things happen to big projects and underground, high-rise buildings, large projects, deep foundations, the things that are going to hit you worst is utilities. I dropped almost $5 million on a recent project soon to be completed because of underground utilities, because another building on site was slaved back to the building that we were demolishing. So it cost us $5 million and 6 months of schedule because it wasn't on the drawing somewhere. Big buildings act differently. Something else on large projects. The schedule of a large project for design and construction, the length of time it takes, is not your friend. You're asking for subcontractors to bid multi-million-dollar contracts, and they won't even take delivery or make orders, maybe 2 years. Pick very carefully what bid packages you open, what bid packages you think you can delay in order to get a better deal, in order to not be orphaned by your AV system that you've got $6 or $8 or $10 million in just AV equipment alone. But if you bid that early, 3 years later, when it starts to go in, it's already been orphaned, and it won't work in 2 more years because it's obsolete equipment. So be careful about the length of the design and construction schedule, and you designers, think about what you're designing and talk to your contractors, and so your CMs especially, if you get them on board early, make sure that you understand it's not just the commodities, it's not just the supply chain. Everything you do in a large project has supply chain challenges, significant ones. Not just the COVID years now. Big projects are just different. Some things that we see, that we don't see rather, that are costly. Limits of disturbed area on civil drawings. Pushing buildings too close to right-of-ways, too close to property lines, too close to roads, where they have to excavate for a basement or a sub-basement level. Designers have no dog in the design or the construction or the cost of the retaining wall systems around your big buildings in order to get down deep enough to do pile caps on 80-foot deep piles. But those retaining wall systems cost a tremendous amount of money. Find your means and methods that are going to cost you the most money and wrap your design around those. If you've got enough money to dump a few extra $1 million into a buried retaining wall system that nobody will ever see, knock yourself out, that's great. But that money is saved, and you can do cool stuff if you don't bury it underground. Big projects in high-rise. A high-rise has a tremendous volume of external envelope, right? It may be physically the single largest thing, except maybe dirt and concrete, right? Your exterior envelope. Where's it going to be made? Is it unitized? Is it fabricated off-site in another state? When it gets delivered to the site, do you have enough room to set that stuff down? You can have dozens and 100 pallets that are 8 feet square and 8 feet tall sitting around a site. If you can't fit it on site and it has to be stored off-site and you pay for stored materials or you have to order it at separate times, then you put more risk on your contractor and subcontractors. More risk equals higher bids. I encourage our architects and our civil engineers, identify the contractor staging area based on the size and the delivery schedule of those super large commodity packages, right? Make sure you have enough room indoors where you put your doors when they come in. Those are really important considerations. Tower cranes, vertical circulation, construction cranes, or construction elevators, buck hoists. Make sure you understand where those things are going to sit, where they're going to build the foundations for, what's going to go around them. Make sure you coordinate your utilities with those things. They're heavy, they're big, and they stay there for a long time. One interesting one that's really hard to get a handle on, but it's really important. You have to think about the spaces in your big buildings, your volume spaces, they're going to require kind of community scaffolding systems, right? Who does those scaffolding systems? How long do they stay? Who pays for them? Do you ever get into a sequence where you have to constantly put scaffolding up and take it down for the same subcontractor? On a high rise, you can have a set of prefabricated stairs 2 or 3 floors high. But they have to use those as exit stairs too, right? They have to be safe and get off the 8th or 9th floor. And there's temporary stairs, and there's cost to that. Think of your contractor of how you can unitize stuff and accept those different products that are built off-site and they're plugged in faster. You don't want a drywall company or a painting company to have to mobilize 6, 8, or 10 times on your project if you can avoid it by talking about it. Because that increases your cost, right? It's costly things that you cannot see, but you're paying for them, Mr. Owner. Y'all didn't smile at my nod to the Mardi Gras masks. So, one thing you get on big projects these days is maybe the single most innovative and most valuable thing that we ever do. And that's building information modeling, class detection, and resolution, the softwares. Typically, it's done, and the subcontractors do it, and the contractors do it, and they coordinate it on site. Our design team did it, and then the contractor and the CMs did it again and did an excellent job. I can tell you that designing your building before it's finished design, using the BIM modeling, will pay you so many dividends. From an owner's perspective, it's errors and omissions, right? These are big deals. These are 18, 22, 24-inch pipe, chill water pipes going laterally for 300 or 400 feet. And there's 4 or 5 of them, even numbers, 2, 4, or 6, right, Dave? They never come in odd numbers. Loops don't work really good with an odd number. Yeah. So think about that BIM modeling done as a basic service, or even as an additional service that the owner was willing to pay for during the design phase. It really makes a lot of difference. It'll give you a better cost estimate, right? It'll give your budget some relief and predictability, because those systems really are expensive and you just don't see them. How much does the state construction office charge for inspections or visits or advice and counsel, good looks and personality? Anybody know how much we charge designers and contractors? There's the first hand came up right there. Yes. Yeah, zero. Zero. So I'm going to put a plug in for things to do early and often on big projects that you can't. How do you eat an elephant? Anybody? One bite at a time. You better do that with large projects. Find an area, have all the trades finish an above ceiling area. Pick a 10,000, 20,000 square foot, get every trade in there, get them out of sequence, get them on board, have state construction come out and look at your above ceiling, right? Look at all those requirements. Get a sign off. Now you've got an example of what we expected for the other 450,000 square feet of ceilings, right? Do the same thing with your fire protection systems. Do your same things with your generators. When you crank generators up, there's a lot of rules for generators, guys, and it'll cost you 60 days of general conditions when you can't occupy if you can't get your generators to come on in 10 seconds. Did Bob come in? Bob would be dancing right now because I mentioned his generators. But honestly, to fix things at the last minute, speaking of last minute, any commissioning agents in here, any engineers in here that do commissioning? I've had a great commissioning agent the last about year and a half or so, and what makes them great is they're out in front of issues and they don't wait to the last 90 days and come up with a grab bag of things for everybody to do. It's way too late and too expensive to fix things. What happens on a project usually is half the things they come up with essentially are accepted because we don't have a choice, because you have a residence hall and you got 500 new freshmen that are coming in. And those are real stories. Everybody knows that. So don't wait till the last minute. Talk to folks and call state construction, because we don't charge, and ask us for help on the front end. So I'm going to turn this over to Chris Roberts. Thank you.
Thanks, Will. So from the most simplistic definition of a high rise, you're talking about a building that has an occupied level that's 75 feet, not above the ground, but above the lowest level of fire department vehicle access, right? And so that is all based around where the fire truck is going to come, they're going to park, and with a ladder truck, how are they going to get to that highest level? So it seems simplistic, right? But not all projects are so simplistic. You have to work with the local fire marshal to understand how they are going to fight that fire. And so while the state construction office is the ultimate say and the AHJ that gives you the thumbs up or the thumbs down on how you've planned something, a lot of the times they will defer to the local fire marshals to make sure that we're talking with them. As an example, so at UNC, the Keenan Flagler Business School, we did an addition. So the building right in the middle of the slide is the addition. It actually attaches to a parking deck. So the parking deck and the addition become one building. and it bridged over Keenan Drive to the south to attach to the McCall building. At the time, we were trying to figure out were all three of those structures going to be looked at as a single building, in which case it would add a whole other complexity to things. But to add to that, so the parking lot to the east, we'll call that baseline elevation 0. And on the west side of the addition was a big ravine, actually, where a stream came down, the park to the left. That was also at baseline elevation 0. We knew our addition was going to be higher than 75 feet above those 0 baselines. When we met with the local fire marshal, they said there's no way that we're going to come and fight a fire through the parking lot. We would come to the road at the top, Blythe Drive, which is 43 feet above baseline, or Keenan Drive between the two buildings, which is 22 feet above baseline. So when you consider that, those trucks are already high enough above ground or above that 0 foot baseline that they can get to the highest level of the occupied floor, much less than 75 feet. So we're able to avoid having to kick ourselves into that high-rise designation. This is just another look at it. Blythe Drive is in the foreground at 43 feet. They're only going up, 35 feet to get to 78, so well below the high-rise determination. So, a group that you may not normally think about as being an AHJ, but they do have authority, and they have a lot of authority. Michael Shumsky referenced this in his comments this morning. But when you've got a high-rise building, you always need to think about contacting the FAA or going through their process. So they have a form, the 7460 application, which is generally required when you're within 20,000 feet of an airport or have a building over 200 feet tall, but not always. So you go onto their website, you fill out this form, you submit your coordinates. You can get those off Google Maps. You enter your grade above sea level. You enter how high your building is going to be. And then it spits out and it tells you if you're actually required to submit your building for them to review. So you know you're having a bad day when on a Friday afternoon you get a letter from the FAA saying that your building is 9 feet too tall. And we were 35,000 feet away from an airport, and the building was only 185 feet tall. We had figured out late in the game that the crane was actually going to be over 200 feet tall, which kicked the contractor into having to submit for a permit through the FAA for their crane. And as part of that, they came back and they said, hey, we need to submit the 7460 for the building too. So we submitted it. 2 months later, we get a letter from the FAA that says we're 9 feet too tall.
The worst summer ever.
Yeah, and then you have to call this guy. Not fun. But anyways, so I'm not going to go through this whole timeline, but after we were notified from the FAA, and their reasoning was not that our building was too tall or we were too close to an airport, but that we were going to block some of their radar. You know, there's a helipad right next to where the site is. We weren't sure if that was going to be part of it. It wasn't. But it was because the building was going to block their radar and we were 9 feet too tall. So after we got the notice, 2 months after we submitted, we said we wanted to appeal. They said it was going to be 45 days. We said, that's fine. 45 days came and went, then it was 2 months. Called them. They said it's going to be another month. Called them, said it's going to be another month. So they do not stick to their timelines. Let's be clear with that. So it was about 10 months later, after contacting them many times and actually having a meeting with Will and Michael Shumsky to talk through what the issues were, that we were finally given the go-ahead to proceed and proceed with the building as designed. We were literally hours away from pulling the trigger and trying to take 8 inches out of every floor to get the height of the building down to get under that 9 foot. So you don't want to be stuck in that point. just be sure if you're going to do anything even remotely close to an airport that's got some height to it, submit that form. The fun thing, we were already under contract with the steel contractor going through shop drawings. So if we needed to change everything, it would have been a real big deal. Again, coordinating with your local aid or the local fire marshal on campuses with multiple buildings. DHHS is an example. It is actually, so it's a parking deck and then the central plant and tower are connected. So 2 buildings on site. We actually looked at those as a single building. You can do that when those buildings are in close enough proximity to each other. But we needed to know where the fire marshal was going to come and fight a fire from. And so we worked with them, figured out that where they were going to approach the project from, where they would fight a fire from. It helped us figure out where we need to design turnarounds for them, what needed to be rated for fire trucks, where we needed to locate FDCs and so forth. So they determined they wanted to come in right off Reedy Creek Road. The fastest place that they could get in was in a secure service access area. And so it was right near the fire pump room. And so we had to figure out all the stuff that was needed for them to come and do that. This isn't unique to a high rise or, this is just something that you need to do as good practice with all of your buildings, meeting with the fire marshal first. And they appreciate it. They say, we're not the ones that will give you the final approval. State Construction still gives you the final approval, but it goes a long way. The fire command room is required when you have a high rise, and just in general, this is the room where the firefighters come to first so that they can monitor all the building systems, they can control the elevators. So this is the place that all the rest of the time, it's just a room that sits there ready for an emergency for the firefighters to use. And the important thing here is also to talk with that local fire marshal to figure out where in the building they would prefer that building to be, or that room to be. And it's not going to be the same answer every time. The city, again, they'll leave it back to State Construction to give the final word. But 2 case studies really quick. These are both with the city of Raleigh, the Albemarle building in downtown Raleigh. We renovated that. At the time, this was back in 2015 when we met with the fire marshal. That fire marshal said, we want that room as close to where we're going to enter into the building as possible. So you can see that the arrow on the left is where they're coming in. We put that fire command room right there. When we did the DHHS building, same fire marshal, they said we would rather have that room be located as close to the fire service access elevators as possible. And so you can see kind of circled in the middle, that is where the fire command room is. And just next to that is the elevator bank where you'd find the 2 fire access service elevators. Paul Kitchens.
All right. So when the fire department arrives at the building, they're going to need to take into consideration what the condition of the building occupants are and how that relates to how they fight the fire. Most buildings that are not high rises, they're not of this magnitude. When the fire alarm goes off, everybody evacuates and you shut down all of the building HVAC systems to avoid migrating smoke from one floor to another. If it were to be appropriate to leave some folks in the building, of course, this comes into play in healthcare and other institutional occupancies. But in a commercial building, if you were to try to keep some of the floors operational, that has significant implications to how the fire alarm system operates and in turn how the HVAC systems in the building need to respond. In this case, for DHS, we did not end up trying to keep anyone in the building. It was determined it's appropriate to let everybody evacuate on a fire event. Now, a large government building has other emergencies that can occur aside from a fire. NFPA actually has a risk assessment that you can work through. It's a work form where you sit down with the owner and talk about what risk, what threats to the building need to be taken into consideration. It can include wildfires, seismic, active shooters, things like that. So on this project, we worked through that with state construction, talking with some of the building occupants to determine which threats to the building needed to be broadcast out to the building occupants. Of course, you can adjust that later, but day one, we have verbal messages that can be broadcast out over the mass notification system. There are different colored lights that correspond to those different types of emergencies. But of course, that won't get out to everyone in the building with different disabilities. So we also have these video boards that if you could not hear the message, they're strategically located so you could read what is the emergency so you know how to respond. You wouldn't want that to be blasting out, trying to fight with AV systems, ongoing with WebExes, things like that. So we have relays in the building to shut off the AV systems when an event like this occurs.
Paul, if I could add to that, I think
Sure.
those messages that that appear, they were first standardized by the state construction office when we did the Albemarle building renovation. And I think they've continued to work those into definitely their high-rise buildings and probably some other buildings. And so when we started DHHS, it was kind of a revisit to make sure that those are the same messages that we still wanted to use in this building. They are customizable, but the state construction office has standardized on those.
Absolutely. And if something were to occur that's outside of those pre-recorded messages, you can, of course, have someone live broadcast a message over that system. All right, this next topic is near and dear to my heart, so I'm going to speak to it for a few minutes here. Not specific to DHHS because we avoided some of the issues, but I've done this at least a dozen times successfully, and I have a few hard life lessons related to pressurization systems. I'm going to tell you how to avoid those. Stairwell pressurization is required for any high rise, particularly for the stairwells that are over 75 feet in height. If you have some low rise stairwells that just connect a few levels, they are not required to be pressurized. But pressurizing a stairwell is a very straightforward thing. If you can imagine any door, just the gaps around the edges are fairly well defined. Only real variable is the undercut of the door. We as engineers can do some simple math to determine how much air it takes to pressurize that stairwell and keep it free of smoke so folks can evacuate the building safely. Elevator hoistways are a different story. There's two options in the code when you have a high-rise building. You can provide a similar pressurization system for the hoistway, or you can provide a smoke-rated elevator lobby. The one for DHHS is pictured here in the lower left. That, I will implore you, is the far simpler solution. Easily saves 6 figures, but more importantly, it saves risk on the back end of the project. To make an analogy on how difficult it is to pressurize an elevator hoistway, I'm not going to embarrass myself by doing this with my face, but I'm going to paint a picture with my words. Imagine blowing out birthday candles on a cake, the face you would make, what the air looks like. Then imagine opening your mouth wide and trying to do the same thing. How much force are you going to get from your breath? That's what we're dealing with elevator hoistway pressurization. There's an annular opening around the doors. There's a gap between the doors themselves. But when you perform this test, the doors are required to be open on the floor of recall. And next time you're in an elevator, take a look. That gap is anywhere from 1 to 2 inches wide. I've seen it as far as 3 inches wide. Granted, with something to prevent people from putting their hands in there, but not blocking air. When you have a hole that big, it takes a tremendous amount of air to achieve the desired pressurization. If you're doing the calculations, you have dozens of variables, including temperature, the tightness of the building, the tightness of the hoistway, the gaps that I was just describing. And if any one of those goes awry, your calculations are not good for much. So do your calculations and double it, and you got a chance. That's my recommendation. But that being said, even if you blow the right amount of air in to pressurize the elevator, it's so much air, you can have a negative impact on the operation of the elevator. If the firefighters are counting on using that, you can make the cables, or nowadays the belts, sway in the shaft to the point that you're tripping on safeties. And of course, every elevator manufacturer is going to arrange their things different ways. So unless you pre-qualified somebody and know how they're going to configure in the shaft, you don't even know where the right place to put the air is. So whenever possible, please consider elevator lobbies. Because when you, the thing I stumbled over here is when you're testing these systems, you can't do it 6 months out to make sure you're safe. The building has to be fully enclosed. All of the doors and windows have to be in place. The envelope has to be fully intact, and that's usually the 11th hour when the owner's ready to move in. So do yourself a favor, provide lobbies. You won't get into that situation. All right, this topic is not specific to high-rise buildings, but of course, as Will alluded to, high-rise buildings are of the scale and magnitude that they often need this type of system. Emergency responder radio communication systems. There's so many acronyms for this, it's very confusing to the point that I screwed up the acronym on the slide here. But all the things that people call this is a way for the first responders to talk to one another in the building. It was added to the code after 9/11 when there were transmission issues in the buildings. High rises have three factors that make this type of system likely to be needed. The footprints are often very large, so you have more walls obstructing the signal. They typically have a good deal of glazing with low E coatings, which also blocks RF signals. And then typically when you're digging out the foundations, you go so far underground that you have some basement levels where these signals can be obstructed. So you don't really know if you need this system until you go out and test when the building's constructed. Again, that's too late. So what you need to do is plan for this system up front. You need to count, or you need to have a spot identified where the antennas may need to go outside. You need to have a room inside that's 2-hour rated where that head end equipment can go, and then vertical pathways for the cabling. If you build in that infrastructure, then when you do the testing after the building's under construction, you're ready to go if the system is needed. So one of the success stories of DHHS was a very intentional effort to have the program stack vertically. The core is very efficient. We were able to locate the mechanical, electrical, and telecom rooms where we only needed one of those on each floor plate, and that allowed a great degree of flexibility out in the floor plan. This drawing you see in the lower right is intended to be somewhat sparse. This is a shell and core plumbing drawing. You'll see there's not risers all throughout the plan. We were able to stack all of the elements that needed drainage in specific locations to leave the floor-to-floor height as clear as possible for optimal ceiling heights. In the lower right-hand corner, you'll see the only riser that was not in the core. That's where we have a pantry with beautiful views out over the art museum. That's the only plumbing riser outside of the core, and that led to a great deal of program efficiency.
All right, so when we get to the envelope, and specifically talking about your glass and your glazing system, you've got options, right? There's tempered glass, there's heat strengthened glass. You can't use heat strengthened everywhere. And I think tempered glass, at least in our firm, is generally what we try to use everywhere, unless there's different situations that require to think differently. So tempered glass is stronger than heat strengthened. It's about double. But the interesting thing is that the industry allows for a certain percentage of tempered glass to spontaneously break. It's caused from nickel sulfide inclusions that you can't see with your eye. They get baked into the glass. And then when those pieces of glass are out in the field and they get hit by the sun and they start to heat up, that tempered glass will spontaneously break. And so you would think that that would fall under a warranty issue, but it doesn't. It is actually industry standard. They write it in their contract, and then the owners end up paying extra for it. The cost difference between tempered glass and heat strengthened glass is really not that big of a difference. With tempered glass, you can actually heat soak it. It's called heat soaking, where they actually heat those panes up in the lab, get them to a high temperature, and then let them cool down. And it's basically meant to mimic the same conditions that you would get when the sun hits those panes out in the field and causes those pieces to spontaneously break. And so it catches most, but not all. And I think the important thing to know here is that the state is really risk averse. So when you talk about, hey, there's a chance that your glass on the outside of the building could break, that's not something they want to hear. So have the conversations with your owners early, do your research to determine the best path forward. But code permits you to use heat strengthened glass in a lot of areas on the outside of the building in high rises, to the point where if you see the diagram on the right, the blue panes are actually the only panes on the DHHS building that ended up being tempered glass, because the rest could be heat strengthened. The tempered glass were required for the smoke removal. It's a code requirement, and every 50 feet or less, you have to have panes that the firefighters can come and easily crack those panes and get out for the smoke removal. So have those conversations early with your client to understand their risk and their appetite for that. Yeah.
For the record on DHHS, we did every manipulation of the glass envelope that is available to mankind on this building, because some of you might have been familiar with just a few short years ago in downtown Raleigh, we had a state building, and a lot of people had a lot of fun with that. They had innumerable panes of glass take off and fly to the ground. They did not do it like we've done it. There is no 100% solution. Almost every building has a significant amount of glass. There's still a 3% error factor. So if you have 100 windows in a large building, wouldn't be unusual to have 3 of them have an issue with glass at all. But we did everything we could do. We did heat soak every piece of glass out there.
That's right. And when it, especially on high rises, our firm tends to go with unitized curtain wall systems. So it's something we do most of the time. I noticed on the Pendo building in downtown Raleigh, when that went up, that was actually stick framed. I don't know the reasoning behind that, but you will see both done. We think the unitized systems are much better. They allow you to dry in your building a lot quicker, because those units are fabricated in a lab, in a shop, where you can control the conditions. You're going to get better quality out of those systems because they're built in a controlled environment in a shop. Some things to be aware of is that there is a limited supply chain for those. And then when you do find the firms that are able to do that, they have different details. So just know that you're going to have to work with, if you have a basis of design and 2 equals, you're going to be working with at least 3 companies to figure out what their details are and baking those into your drawings. And then I mentioned the fire service access elevators earlier. So those are the elevators that return back down to the ground floor. Typically, it's wherever the firefighters want them to return to, so that they, when they come and they get into the fire command room, they can control those elevators. They can get into those fire service access elevators quickly, get wherever they need in the building. One of the interesting things is that you have to design your elevator lobbies so that when the sprinklers go off, no water actually gets into those shafts. So if you can think about that, you either have to design some sort of handicap accessible threshold. In the case of DHHS, we actually tapered the concrete away from those. It's so subtle that you would never know it just walking in the elevator lobbies. And then we had a little bit of a threshold as well to help with that.
All right. Again, related to egress pathways in the building and systems related to those. If you have a building like DHHS where each individual floor is dealing with sensitive information, the floors are locked from the stairwell side. So once you go into the stairwell, you need to work your way down to the exit point of the building unless you have a card that gives you the appropriate access. When you do that, when the stairwell doors are secure, you have to have a means of communication in the stairwell in case someone were to get trapped there and not know how to get out. And so every 5th floor in a high-rise building, you have these these audio call devices in the stairwells. Additionally, this is not really a high-rise thing. This is any building 4 stories or more. Current code, you have to have communication devices in all elevator lobbies. This ends up being a multi-trade coordination thing because it has to have appropriate signage. Elevator lobbies are typically a high finish area. So the design team on the engineering side and the architecture side has to carefully coordinate where these are going to be located and what the signage is going to say.
Paul, can I add something to
Yes,
this?
sir.
So I took this finalized presentation and printed it out on a color copy machine and couldn't remember which color copy machine I used. So I blew it off and did it again, and the copy that I couldn't find made its way back into our design review section. So Paul may not notice. He said 4 stories or more. The comment I got from our design review section, which they disagreed with the 4 and told me it was 2. So if we don't have it, we're probably going to have to get it. We should have it, I'm sure. But that's where that 2 came from. We can talk later. And Matthew Marbois, you could be my co-pilot because you're the one that changed that number from 4 to 2. It never happens that design review changes anything on you, I'm sure. I'm certain of it.
I had not encountered that before, so I will learn up. This is more of an architectural topic, so Chris, feel free to chime in. But our building does have a special provision that's really great for the occupants of the building. Every 2 floors are interconnected by communicating stairs. But as I understand it, the new code update will no longer allow that.
Yeah, I think the answer is it depends.
Okay.
So do your homework. Pay attention to the new code.
All right.
But we did those connecting stairs between the break rooms on floors. So connecting two floors together to promote health and wellness and, community, and be able to bring, you hear people on the floors above or below you, and you get interested and you go down and see the people on the floor above or the floor below you that you wouldn't normally go and see.
This next topic was very much a Bob topic, so I hope he catches our next session. This is not specific to high-rise construction, but large buildings have lots of large motors that are operating at variable speeds. And when you have that, you have the potential to have harmonics in the electrical system. And harmonics for non-engineers is a dirty waveform that can cause issues like flickering lights and sensitive electronics to not behave as intended. On top of the variable frequency drives that we have serving our HVAC motors, LED lights actually impart some harmonics, as do all of the computers and laptops in the building. So this is a growing problem where harmonics issues are being observed more often, even when a VFD harmonic study indicates that it may be okay. So there are a number of strategies to avoid harmonics being an issue in your building. In our case, we specified variable frequency drives for the motors that have some robust features to help limit that harmonic input to the building. What I want you to take away from this picture is those drives are much larger, more costly, and you have to plan for that in the design. If you defer to a later submittal stage to determine that, it might be too late if you didn't allocate enough space. And you'll certainly get into an argument about who's going to pay for these filters. So what state construction would like you to do as a designer is do a preliminary study. Now, it is specific to the vendor and the drives you're going to get. So, of course, in an open bidding process, you don't know exactly what you're going to get. But you can work with a VFD manufacturer to get some specific information for your project for what the layout may be and what the impacts are likely to be to your building, so you can fold these provisions in and avoid surprises later.
And just a couple other parting thoughts before we wrap up and take questions. A couple other considerations. The luminous markings that you see in the stairwells of high rises are always a fun challenge. They don't ever look great, but know that you're going to have them. They run down the tops of the handrails and are on the nosings and the risers of the stairs, so that in an emergency, those glow in the dark, so people can find their way out. The other thing is to think about window washing, right? Most projects, we don't think about that because they can wash the windows from the ground. When you get into high-rise buildings, it doesn't even need to be high-rise. When you get into taller buildings, think about that with your owner. Talk about how they're going to do that. Are they going to hire a service? Are they going to do it themselves? What type of platform or chair do they want to have for that? Because that's going to change the structural requirements and where you put anchors up on the roof. So just a final comment. So we had the inaugural pre-conference tour yesterday at DHHS, a high rise. I think they're hoping to do this every year, so be on the lookout for another project tour next year. Can I get a show? How many people here actually went on that tour? That's awesome. Good number of people. Thumbs up. Was it a good tour? Do it again next year. All right.
Not the same project.
No, different
No,
project
no,
next
we're
year.
gonna have somebody else will volunteer a brand new building for your enjoyment.
Yeah, and if you scan that QR code, that'll take you to a website that tells you a little more about this project in particular. They've got a pretty cool time-lapse video on that the contractor put together for us, Belfort Beatty, Barnhill, and DA Everett. So yeah, thanks for coming out to that, and look forward to next year's. And thank you all for being here. And I think we've got about 9 minutes left to take some questions if anybody has any. You can either shout them out or it looks like they've got a microphone set up down here at the front. Any questions?
I think you presented on tempered glass versus heat strength. You talked about the tempered glass coming with 3 panes per 1,000 as the industry standard. Talked about heat soaking as a potential measure to mitigate, but is that only, are those two issues only for tempered, not heat strengthened? Is that why you went with heat strengthened?
That is correct. So the question was about tempered glass and the spontaneous breakage associated with that and the heat soaking to minimize that. And is there, does that only pertain to tempered glass or is it also pertain to heat strengthened? So the answer to that is tempered glass is the only glass that will spontaneously break from those nickel sulfide inclusions. And while you can pay a lot of money to or pay money to have the tempered glass heat soaked, go through that process and try and find those panes that are going to break out in the field early. It's not 100%. All the glass companies will tell you it's not going to find every pane. And so I think the warranty ends up being the exact same thing. You just reduce your risk. When you get into the heat strengthened, you don't have, it's not the same process like the chemical process of how they do tempered glass where it breaks into tiny shards. And so they don't have that problem with those nickel sulfide inclusions being able to spontaneously break that glass. So actually, the inside pane ends up still being tempered. The outside pane ends up being heat strengthened. And then the panes that you saw in blue on that diagram, those are both tempered so the firefighters can get in quickly. Yep. Any other questions? You guys don't want me to sing. I'm not a singer.
Do we keep telling stories about big buildings? I'll have to say that these two, and I'm gonna call them our lead design firms because we have a whole litany of firms on the project. But I'll have to say that the cooperation between Newcomb and Boyd and LS3P on this was superlative. These systems within the building are very large. Every single piece of equipment is as large as you're ever going to see. On big buildings, don't try to skimp 20 or 30 extra square feet in any of these buildings, whether it's your fire alarm panel or your control room or these buildings, it's really not worth it. Because one thing that I learned, some of the things I've never seen before are on this buildings, because all the systems were pretty new to me. They're large, and there's a lot of them in the room. That control room for the fire department, 350 degrees, except for the door coming in, are completely covered with panels and boards and enunciators and conduits, and it actually is a work of art if you like alarm systems and fire alarm systems. So keep those rooms as large as you can. And my last word is on large buildings, stick to your early designs. Don't allow changes. Don't allow your users to change it. You've got to have a significant discipline in your design process, because when you change things, your error rate increases, your risk increases, money goes out the window. You don't really get any added value. Designers, work with your owners and hold the line, right? Because we all have clients that we're delivering buildings for, right? And that's one of the biggest things you can do. So
All right.
thank you.
Thank you all for coming. Enjoy the rest of the conference. Michael Shumsky's gonna be proud. We finished 10 minutes early. Thanks, y'all.
Good. They get back. Yeah.